one more question. Question number 8. How do decantation and filtration differ? Which should be faster? Okay, so let me make a little table. So I'm no artist, but I'm just gonna try draw out what decantation looks like. So basically for decantation, your solution is either slowly poured out or you can just transfer it out using a pipette or something. But basically, you have to wait until your particles are settled at the bottom. So in this case, it's red. So I'm gonna write that down as well. Need to wait for particles to settle before you start pouring it out. So it seems pretty easy. However, this method is, say, less accurate. I'll call it not too accurate of a method. Okay, so let's compare this with filtration. Let me try to draw it out again. Okay, so you can see with the filter that you don't need to wait for any of the particles to settle or anything. And what filtration does is that it allows definite sized particles to pass through. And then the rest is collected in the filter. So filtration is more accurate. So it doesn't rely on the human error, where we would just try to slowly pour out solution and just hope that none of the other particles will go in to our collection vessel. So it's more accurate because like the filter paper that you use, like hopefully it's the right kind of filter paper. It'll just not allow any of the particles that we don't want to go through. So it's more accurate in that sense. But if we want to talk about saving time, I would say that gravity filtration is much more slower than decanting. So it also like depends on how good your filter paper is. So you could have a filter paper that has really small pores, and sometimes it would take like forever for the solution to even pass through it. But if you had a filter paper with like larger pores, it wouldn't take so long. So still gravity filtration is much more slower than decanting. But if we use like vacuum filtration, I would say that would speed up the process by a whole